In a distant future, in an age of intelligent machines, he is the first robotic child programmed to love.
A machine can learn, but can they use what they have learned? Today we are going to introduce zero-shot learning, which is a way to train a machine such that they can use what they have been taught. They can predict a class that is not in the training data set. This is a video produced for the project of COMP7404 course at the University of Hong Kong. In this video, we are going to discuss the paper Zero-Shot Recognition via Semantic Embeddings and Knowledge Graphs written by Wang, Ye, and Gupta.
In order to understand this paper, first we need to understand what are word and image embeddings. Word embeddings represents the meaning of words using spatial coordination. Say for example, the coordination that represents the word table is located near the coordination that represents the word desk. Image embeddings are similar to word embeddings. So an image of a table will also be located close to an image of a desk in the embedding space.
Machine learning can be classified into three areas: supervised learning, unsupervised learning, and reinforcement learning. Although zero-shot learning can be vaguely classified as supervised learning, it can be considered to be a better version of supervised learning. In zero-shot learning, models can infer classes that are not provided in the training dataset.
Okay, how to do zero-shot learning with these embeddings? Previous papers have done zero-shot learning with word embeddings, where they model the relationship between image and the word, such that they can map any image into a word. This paper leverages the following to improve the performance of zero-shot learning. First, semantic embeddings. Second, the relationship between the words, known as knowledge graph, which is extracted from meanings of articles on the web. The word embeddings that have semantic properties can be downloaded from Google, and the knowledge graph can be constructed from Level N Language Learning System, which is a public database which is available online. Last but not least, a pre-trained neural network called ResNet converts image into embeddings. We can then feed this image and knowledge graph word embedded into a special type of neural network, which is called graph convolutional neural networks, known as GCN. The GCN will output a set of classifiers. Using these classifiers, we can then predict the classes for a given test image. Next, let's move on to the demo. Welcome to this demo. So for this demo, we try to predict with the pre-trained model from the paper. So now first of all, I'm going to introduce what we have wrote for this demo. So we put our source code for the demo in this folder, and the data contains all the labels and also some data. And the tests, basically the test images we're going to show you in this demo. And the models is a very important part because all the trainings and the prediction, the classifiers are in those models. For the source code, mainly in this one file, the main program takes one input, the argument image, and then predict from that image. Now let's move on to the demo. Today we prepared three images. The first one is your copy, which you can see that is actually, if you want to describe it, you can call it something like zebra, and also you got the face from the horse. And second one is a Pikachu. Pikachu is very famous for young people because it's a cartoon character. And the third one is a panda, very famous for Chinese people. So now let's see whether we can predict those images with our models. First of all, we are going to predict the label for this copy. Let's see what we have. Okay, so we are running the demo, and then we got top 10 labels for this image. Okay. So you can see from here we can predict something like horses, a zebra, a mountain zebra. Next, move on to this second image, which is a Pikachu as a target. Alright, so you can see it's predicted as hamster and also electronic device, which is related to this cartoon, which is electric characters. Third, panda. Let's see what we got for this panda. To mention that actually panda is not mentioned, sorry, it does not appear in our training and also in the labels. So let's see what we can predict for this panda. Alright, so let's see what we have. We have bear, another bear, something. Okay, so this is actually a good result for us because the panda never appear in the training, but we can predict something like a bear. That's the real meaning of zero-shot learning. Thank you.